time, so keep questions as short and succinct as possible. So, check.
I have 2 questions. 2 hands.
Can we have the right-hand one first, please?
Well, this just sprung into my mind. So, would you? I mean, do you suspect that these models would violate CPT invariance in the sense that if you have some particular Beable configuration which is allowed, which has some non-zero probability, in your distribution, is it the case that the CPT in reverse of that would also be, or might not be, allowed in, have a non-zero probability in your?
Can I think about that?
Yes.
Yeah, I'm not sure. I mean, it wouldn't. Just a comment which doesn't answer the question. And let's suppose I just don't know which way to go at the moment. Suppose the answer was yes. That wouldn't mean that we would. It could be yes at the level of sort of the Beables, but no at the level of any observation that we could realistically carry out. So it wouldn't necessarily mean that there was any experimental implication. But
okay. The second question is just taking an intuition from collapse models, the attempt to make relativistic collapse models. The problem that was sort of stumbling block for ages and may still be a stumbling block is that when you consider things like the mass density centered at single points, it's so local that the configuration of Beables that emerges is completely non-continuous. There's infinite energy production because the fluctuations are arbitrarily large, and the way that was dealt with in the non-relativistic theory was to smear, right? So to take averages of mass densities. But the trouble with that in the Lorentzian case is that there's no way to smear without introducing a frame.
Yeah.
So
so my intuition on this.
Worry about such a thing in your?
Yeah, I need to.
Because you do have T nu of x.
Yeah, correct. I'm not sure my intuition on this is right about collapse models, but the problem is that you get the infinite energy production as a result of the collapses themselves. Is that right?
Yes.
Whereas, in other words, you get it from altering quantum dynamics, which isn't happening here. So a tentative hope, at least, would be, hence you don't need to get into this sort of solution because the problem isn't there in the first place. Yeah.
You're kind of collapsing, but you're just collapsing at the end, right? So you don't think that's going to...
Well...
I mean, yes, you're not...
Yeah,
you're not collapsing as you go, but you're collapsing...
But, yeah, I mean, right, asymptotically at the end. So you're not violating conservation of energy, for instance.
It's just a one-finger comment. And I mean, there's a related technical problem, which may or may not be serious in the end, but it's very dubious that the stress-energy tensor restricted to a lower dimensional, a codimensional 1 manifold, like the hypersurface, is well defined at all. I mean, as you know, even the field operator itself, before you start squaring it, has difficulty in general being defined without smearing both in space and in time. I think there might even be recent theorems that tell you, or semi-rigorous results, insofar as quantum field theory is rigorous at all, as you said. But there might be results that tell you even for the single field operator in an interacting field, it can't be consistently restricted to a hypersurface. And for stress energy type of thing, which is quadratic at least, I think it seems very dubious that it's actually well defined.
Yeah.
its restriction to a hypersurface?
That's something else I should spend more time on thinking about it. So, I mean, let's summarise from both of those things. If you end up needing to smear these things in order to make any sense of them, prima facie there's a problem. I mean, maybe somebody can find some covariance smearing recipe that works in this case, but it's not obvious to me how to do that. So those both sound, or at least separately or together, those sound like very live worries. Thank you.
Okay, we have a couple of fingers in the fingers. Are these both fingers? Hands. Okay, so I don't think we can fit 3 hands in the world. Okay, so that was first.
You're probably not surprised that it's hard for me to understand your motivation. So I would like you to say a little more.
About the motivation.
You have a theory which talks about some hypothetical, mathematical, possible measurements. It talks about probability. And you talk about reality. What's real about it?
Guilty about
Then, from your remark to Faye, you say you understand that there is no tension between many words and Lorentzian variance. So how? For me, it's 10 orders of magnitudes the comparison between these two approaches.
Yeah.
The one there is a real ontology, clear, without questioning. Everything is known and understandable. You put some of it, ABL, which is part of quantum mechanics, it's done nothing more than it, and add all kinds of constructs completely, I don't know, what is the intuition to make this complicated theory?
Here I think is the difference between us, on this point. You believe the measurement problem has been solved by many words. I don't. What I said to Faye was...
It's not belief, you have to say what is not solved.
Yeah, well, indeed. So, I mean, I've written more than one paper on this, as you probably know. I think the problem of probability, the problem of structure, neither of these have been satisfactorily resolved, despite many attempts. But, I mean, we shouldn't get entangled in a debate over many words now. Isn't that why you think there is no motivation and I think there is? You believe many worlds solves the measurement problem and everything's fine. And if I shared that belief, I would be with you. I would say, yeah, why add this extra structure? But rightly or wrongly, tragically or not untragically, I don't share that belief.
I think the remaining hands will have to be incorporated into the coffee break. And we'll return here for 4:30. So let's thank our speaker again.